Thank you so much for coming this morning to our webinar. I'm so excited to be kicking off February with Jon from Mode40. I just want to say hello and thank you. I am the Events and Engagement Coordinator here at TMA. My name is Sarah Ann Ellis. I am now going to throw this over to Jon French from Mode40 for his information.
Hi everyone. Good morning. Thank you, Sarah Ann. I appreciate you offering the opportunity to come in and speak to the TMA this morning about smart manufacturing industry 4.0 and how technology is impacting manufacturing from small and medium size all the way to our large and multinational manufacturing sectors across the world. It's really changing the game. Okay, let's dive into it. I'm gonna share my screen here, and we'll get into. Okay, fantastic. So yes, we're going to be covering maximizing manufacturing potential with data, cost reduction, and profitability today. Before I go ahead and start with introductions and tell you a little bit about myself, and then roll into Industry 4.0, smart manufacturing, data collection, contextualization, visualization, etc. I want to start with this meme here. I think it's somewhat applicable from what I understand to the TMA membership, small to medium-sized manufacturers that are leveraging a manufacturing execution tool, and we don't know what that is oftentimes. And it's a tool that you guys use on a daily basis to complete production, to fulfill your orders, to improve your efficiencies, right? And I saw this meme on LinkedIn the other day, and I want to share what a manufacturing software often is. And then when we pull that cape off of the Scooby-Doo meme here, it's often Excel, right? And that's how we get things done, and that's okay. It's better than pen and paper, but there are some other ways to do data collection and visualization. So let's go ahead and dive into the presentation there. Thanks everyone again for joining. My name is Jon French. I'm a global sales exec for Mode40, and I lead our continuous improvement initiatives. So a lot of our solutions identifications, I'll go into a manufacturing facility, walk around with the plant manager, director of operations, owner of the business, understand their business goals, where they're going, where their business is heading from a directional standpoint. And then how do we create a plan where technology can enhance and support that business objective? A little bit about my background: industrial engineering, Western Michigan University grad, primarily focusing in the engineering and continuous improvement functions, and then found a lovely spot in the lean manufacturing world. I've implemented and consulted technology, and I believe it's 206 facilities now, all across North America. So have a great deal of experience understanding business challenges, what is the current infrastructure, and how do we tailor a solution to meet the client's needs. Experience in technology development, implementation, and then also I have led numerous frontline training sessions on overall equipment effectiveness. Okay, enough about me. Let's dive into the good stuff. So content and agenda, what are we going to cover today? We're going to talk about Industry 4.0. We're going to talk about the business objective. We're going to talk about the power of data collection, transforming data into information, something that we can use. We're going to talk about employee impact, and then I'm going to show you guys some use cases and customer stories. So what is Industry 4.0? There's lots of jargon flying around the manufacturing community about what Industry 4.0 is. To fully understand Industry 4.0, let's start with the first industrial revolution. Think of your trains, think of steam engines, think of being able to transport, right? This is really the first revolution. Then into the second industrial revolution, we see the idea of mass production. Think Ford, Model T, assembly lines, the introduction of electricity. Industry 3.0, we introduce these robots, case packers, automation, right? Things starting to get cool. And now Industry 4.0, we are connecting all of the devices across our enterprise and enabling a cohesive ecosystem of data transfer and data flow. So that's Industry 4.0. What is smart manufacturing? I want to take a quick pivot there. Smart manufacturing is the enablement and empowerment of our frontline operator, right? Sometimes we get lost in data collection and optimization, but what is Industry 4.0 and smart manufacturing as a whole? It's how do we give our workers tools that they need to do their job? So just wanted to do some level setting around Industry 4.0 and smart manufacturing. Now let's talk about the business objective before we get into how do we collect data, how do we contextualize it, how do we visualize it, and how do we make it useful? So before any Industry 4.0 or smart manufacturing initiative, we have to be working towards solving a business problem. Is that we need more throughput? Is that I have a high cost of capital on my floor and it's not running, it's not producing my business money? Is my quality poor, or can it be improved? Is that due to environmental factors? Is that due to standard operating procedures? We don't know. What is the business objective? Rate of improvements, labor retention and reduction. The retention part is an area I want to focus on because Industry 4.0 often has a connotation with let's take those jobs away. But what in reality, what we're doing is providing those frontline workers with the tools that they need to execute their jobs at the highest possible level. Okay. So the power of data collection, let's start to talk about what the end state can look like of data collection. So we have this is a XY graph here and showing the improvements from a lean manufacturing concept in this greenish teal line here, if you will. Okay, most manufacturers have seen a lot of improvements from traditional continuous improvement lean manufacturing practices. But this red line here with these bullet points, quality sensing, factory intelligence, factory dynamic scheduling, these are what the future looks like when we start to create a ecosystem of data within our manufacturing facility. So this is what the end state looks like. What does that mean for my business? Okay. Improved efficiency. We see a 10 to 20% improvement in asset efficiency. Okay. Asset utilization, decrease in changeover time, reduction in downtime, increase in OEE. The second, quality. We are reducing scrap rates, increasing fill rates, increasing yields, 10 to 35%. We're working through reducing costs, whether that's labor, inventory, maintenance cost, and then we are improving safety, which I know is a high standard to all manufacturers. Okay, so where do we get data, and how do we start to how do I solve a business problem that I have on hand? Well, we start by understanding that data is the lifeblood of Industry 4.0. So where do I get that data? Well, I can get that from a sensor, from the Internet of Things, if you will, right? I can implement a sensor, hardwire it back to a centralized location and pull data from that sensor. I can connect to an HMI, a panel that's on the side of a device or asset on the production floor. I can connect to a PLC. We often have PLCs all throughout our manufacturing process. So I can connect to a PLC that is wired to that machine and start to pull data. And then the other form of gathering data would be through API and existing setting up an integration between a digital system. Okay, and this just shows a quick illustration of what that data flow looks like from a high level. From the very bottom level, we have sensors. Now we're talking PLCs on the second level. We're starting to integrate some of that data and capture it all under one umbrella. So data is the most critical portion of Industry 4.0. And if we're not collecting the data, we can't contextualize the data to make use of it. I'll pause there, Sarah. I see we have a quick chat. Yep.
Yes.
Yep. OEE. Yep. Thanks for the question, Bob. OEE stands for overall equipment effectiveness, and OEE is comprised of three main parts. So it is machine availability. How often is my machine running throughout an 8-hour shift? It is machine performance. So what is the rate of speed that production is occurring versus an engineering standard? So if I'm supposed to make 25 widgets a minute and I'm only making 20, I am not at 100% performance. And the last part being quality. If I'm supposed to make 10 good units and I only made 8 good units, my quality is at 80%. So we combine performance, availability, and quality and multiply those together, and that gives us an overall equipment effectiveness score. And then, Bob, just to clarify, with overall equipment effectiveness, you could have a 90% performance, you could have a 90% quality, and a 90% availability, and you only have a 72% OEE. So even if you're running at 90% in all of those 3 metrics, OEE encapsulates the overall performance of the asset. Thanks for the question, Bob. Appreciate that. So transforming data into information. So how do we do that? Well, we want to track KPIs. We want to understand where what's the hook in the PLC? What am I measuring a cut on a stamp? Am I measuring a stamp on a press? Am I measuring a cut on a bag sealer? Am I measuring a widget as it passes a photo eye? So I want to start to track my KPIs. Okay, I want to start to contextualize that data in a way that is useful to the operator. We see some charts here, we see some graphs. At a snapshot, if I'm the operator, I can have a better understanding of what's going on with the piece of equipment. And then the last part of contextualizing, automating data flow is system communication. So I might have a maintenance platform that I want to talk to my ERP platform. Okay, for some reason, there's a business case there. I can connect those 2 systems and allow that data to talk. So transforming data into information. So what happens after we start to visualize some of the data from our sensors, from our PLCs, from our digital systems that we have throughout our manufacturing environment? Well, we turn pain points into profit. So we have an understanding of what's going on in my manufacturing floor. We ever walk through the house when it's dark? You can't see anything. Industry 4.0 is like turning the lights on. I know where to navigate. I know where the coffee maker is. I know where the bedroom is, right? I have a sense of direction. I have an idea of where I'm going. Industry 4.0 allows us to be proactive and not reactive. So we're starting to see trends in data. We're able to historize data and compare that to certain operating conditions, whether that's a person, whether that's environmental conditions, whether that's, and I mean temperatures, moistures, etc. We're able to get ahead of our production instead of reacting to what's around us. Culture alignment, and I'm going to talk more about this here in the next few minutes. It aligns the culture. If you think about a great sports team, everyone is aligned around the same objective, and that's oftentimes winning a championship or something along those lines. But when we think about manufacturing, we want to create the most product at the highest quality to solve a problem for the end user, right? Whether that's shampoo, whether that's a piece of metal, whether that's an iPhone, everyone is getting around a common goal, whether that's specific to your manufacturing, specific to your product. Everyone has visibility on the problem at hand. And then the last part of the turning data into information is the communication. Communication is often known as the root of all the world's problems, right? So if we can improve communication, we can, in theory, see the results from improved efficiencies. All right, let's talk about the employee impact. And when I first met with TMA about giving a presentation on smart manufacturing industry 4.0, employee impact is a high area of what does this idea of smart manufacturing generate for my employees. And we talked about the idea of smart manufacturing empowering the frontline operator to have the right information at the right time to the right person. Okay, so what does Industry 4.0 do for me on my manufacturing floor? Well, it's a tool. You can have your frontline employees access training documents. I've got a project example in here with a kiosk that I'll walk through, but your employees can instantly reference training documents on the production floor in real time. How about our standard operating procedures or how-to? Some of those go hand in hand with the training documents, but I can reference how I'm supposed to execute the production of a widget within a very reasonable time. As before, I might have to radio my supervisor. He or she might not be available. Then there's a time gap, etc. So we're able to reference critical information on the production floor in real time. Alerting and monitoring, right? When something's going down and it's been a certain number of time, who should know? When should the plant manager know? Should he ever know? Should he or she ever know? Right? So when we talk about alerting and monitoring and using technology as a tool, we want our assets and our lines to be running. Let's put some boundaries around if that asset or line is not running, who needs to know and why, and where does the information flow? That can help escalate and resolve a lot of downtime issues for manufacturers and help with response of maintenance repairs. Okay. Communication, we just talked lightly about that one. Production metrics, Bob, back to your question with OEE, we're able to visualize how often our machine is running throughout the shift, the rate at which it's producing product, and the quality of the products that are being produced. Quality data, we'll move on to production scheduling here, right? And this is kind of in a flow, right? If I'm a plant manager, how would I want my employees to be able to access this? Maybe with red being the most critical and green being nice to haves, if you will, as you move towards your maturity state in the Industry 4.0 progression. But production scheduling, I have the ability to see what's coming next. I can reference training documents and SOPs ahead of time if I'm working on a SKU that I'm maybe not familiar with or need some training or tooling on, right? So I'm able to see what's coming down the queue. And then the last one being machine data. Think vibration sensors, think pressure, think the overall health, the EKG of the machine. So we talk about employee impact and delivering information. We talk about delivering it to the right time, at the right place, to the right person. I'm going to bounce back just a few slides here. When we talk about this here, contextualizing and automating data ties directly back into right time, right place, right person, or system. All right, so I'm going to start with the level of sophistication here. So we'll start with simple and we'll move towards, we'll call it more advanced for our use cases and customer stories. Let's start with the check weigher, right? What can a check weigher, what does it mean for my check weigher if I were to potentially integrate this data and understand the data to better run my business? And here's an example of one. So we had a check weigher on a fill line. This was a manufacturer that produces liquids of different densities, and they were having high giveaway and losses with their different SKUs. Like I said, those products ranged in density, so they were having a hard time adjusting the flows and some things like that to make sure that the check weigher was getting the correct weight and the SKU was passing, we'll call it the quality inspection, right? So by integrating this piece of equipment, we were able to identify that there was a single source of truth error coming from the check weighers themselves. So we implemented a solution to integrate an inline flow meter, right? And then we created a new standard process to recalibrate the flow meter and the check weigher at a standard defined time. And then once we are able to have the flow meter implemented, we tied that back to the check weigher, which gave us a new single source of truth for data that was flowing from through the piping into the filling, and then would be weighed at the check weigher. And what this enabled for the customer was an alarm system when the sensor drift would go too high. And really what that meant for us is the statistical process control was out of line. So what did that mean for the customer once we were able to provide them with real single source of truth data from the inline flow meter and the checkware? We were able to reduce giveaway by 2%. This was a savings of over $1 million per year, and they scaled this solution to 10 plus sites. Right. So what does that mean for a business with we'll call it under $100,000 investment, yielding $1 million? Sign me up. Okay. Next, let's talk about asset uptime. This was a project not too recently ago. We had a manufacturer producing plastic resin, and they were having uptime issues with their most critical asset, which was their extrusion machine. So what was the problem? Throughput. They need more product, kind of a common goal across our manufacturers. And we wanted to keep that expensive piece of equipment running. We deployed an overall equipment effectiveness system onto the machine to start analyzing performance, quality, and availability. And what we ended up uncovering was something very, very unique. But the root cause analysis after a period of time running was we found that certain SKUs ran a lot worse than others, right? And we had to take a step back and look at this and go, well, why are those SKUs running worse? They're the same plastic resin beads, right? Well, they weren't. They were actually coming from a different supplier, a different set of suppliers. And it happened to be a supplier that say they were having some issues with from a quality perspective. So what they did is they reviewed their suppliers and they chose to buy more raw material from a specific set of suppliers. And what did this ended up doing for the business is they slashed their most least profitable product. So this product came from this extremely, we'll call it variant quality that produced their lowest profitable product, which happened to come from suppliers they're having issues with that caused their machinery to be down all the time, right? So we've got four outcomes of running a bad product there. Okay, so they were able to remove the product offering they sourced from the raw material suppliers they're having issues with. They were able to remove it. They were able to spend more time on higher profitable product, and they reduced the overall downtime, the 1 month period after 13%, which meant another $185,000 in additional value generation for the business. Okay. This was another under $100,000 smart manufacturing initiative. We're pulling data. We're understanding why and when things aren't going to plan. We're looking into those root causes, and we've identified a solution that impacted their business very, very, very nicely. Okay, next let's talk about maintenance lead time. This is a common ask in the industrial setting of manufacturing, if you will. So we have an issue with the maintenance team just taking too long to repair the assets. So we implemented an overall equipment effectiveness like system and enabled the operators to start coding and manually entering downtime codes. And then a few of those codes were automatically populated through automation. But what the root cause, we had a lack of timely communication being delivered to the maintenance team. So they didn't know what was down, essentially. The team was relying on cell phones and radios and, well, Susan's busy doing this and Bob's over there, right? There's no centralized location where we can see the status of our equipment in real time. So what did we do? We started to automate the monitoring and alerting based on downtime occurrences and duration. So if my machine's down for 5 minutes, my supervisor would know. If my machine's down for 10 minutes, the maintenance supervisor would know. If the machine's down for more than 35 minutes, the plant manager might get an email, something like that. Not that email is always the answer, but it is another form of communication. So what was the outcome? We had engaged employees. This is a quote from the shop floor. I remember going back and having a conversation. I believe this individual's name was Steve. He said, I have the tools that I need to let someone know, right, that my machine's down. And if he's not, the automated reporting's doing it for him, right? So how long has my machine been down? If there's an automated code, it might send with that alerting and monitoring to let the supervisors of the production area and the maintenance area know what's going on. And then another outcome that we saw was the time to resolution decreased by 22%. That's a lot of time. So we saw an enormous improvement, primarily from engaging the operations and the maintenance team and putting them on one plane so they can all work towards one objective. Once again, smart manufacturing, empowering the workforce with the tools they need to succeed. Okay. And then we saw maintenance department KPIs increase, and the customer saw additional throughput. Okay, let's talk about training and SOPs. I see we're a little bit at time here, Sarah, so I'll pick it up slightly. But we had a assembly line with high volume, high mix. So we're talking a lot of widgets going by the production line. Okay, and a lot of them are different. A lot of different conveyance systems merging on a finish area. Okay, where the employee could add X widget, Y widget, or Z widget. So what we faced with implementing a training and standard operating procedures type project was the reworks were way too high. There was quality defects in my product. So what did we do? We provided frontline operators with the ability to access information through the form of kiosks. Okay, so we created a workstation kiosk. We deployed some tablets to the production floor. Any work cell had the ability to, within like 15 steps, access that kiosk, reference what SKU was coming down the line, check the training modules or any quality callouts that they might have in those documents, and then the employees prepared for, say, unique SKU that might be coming down the production line for them. So quality increased by 8%. That meant $130,000 for their business in 1 month. We scaled the solution across the facility very shortly after. And then I want to come back to this point. We have the engaged employees. I can see what needs to be done in this diagram right here. We're visual. We can see something. We can point to it. We can instantly reference the training and standard operating procedures for a SKU. And then this is my last one here I will discuss on, and this is production scheduling optimization. We had a customer that just felt their production schedule wasn't correct. They had a guy in the back office that had owned the production scheduling for, we'll call it, the last 10 years, and they wanted to take the next step with automating their production scheduling. So we executed call it a smart manufacturing initiative, and we discovered that the production was not scheduled for optimal changeover sequences. We added a customized production scheduling module to their, we'll call it in-house MES, which is a manufacturing execution system. And we're able to automate production scheduling based on a series of constraints and demands within their manufacturing facility. It reduced their overall changeover time by 8% in the 2 months following. That meant $300,000 for their business and additional value generation.
Thank you so much for joining us today, everybody. Jon, I appreciate you in leading this webinar today. This, again, has been recorded and will be sent out later today, including Jon's contact information if you would like more information. So with that, if you have any questions, please feel free to share. Otherwise, have a wonderful day, and we thank you for your time.
Thank you. And please scan my QR code, connect with me on LinkedIn. Thanks, everyone.